Hey guys, Professor Griffin, Python Crash Course, Lesson 13, Dictionaries, Part 2. So last time we did some dictionary stuff, but we didn't traverse a dictionary, and that's pretty important. So let's talk about dictionary traversals. It's pretty much the same as you would a list. So let's say for item in D, print item. So it is a little different though, right? Because obviously a list has single elements or single values at each element, and so item is pretty clear, it's clearly defined. But what's dictionary going to print out for each item? Does it return a tuple? What does it do? So let's see. Okay, prints out keys. Alright, is that helpful? Yeah, we can use that. So we know that, let's actually change this to key since we know it's a key. So I could really just reference the dictionary with subkey, right? And now if I run this again, now I get the values, right? So we could print out key, comma, and I'm doing this little, not a formatted string, just the print statement lets you put comma separated values. It's a little faster. So there we go. Apples, 100, bananas, 200. Cool, we traversed it. But there's a better way. So imagine, let me back up. Remember a couple of lessons ago, I said if we took a tuple of items and we assign that to a comma separated list of variables, it would know that the first item in the tuple goes into the first variable, the second item in the tuple goes into the second variable. Well, same idea if we use this function called dictionary.items. It does that for us. So I could print k, comma v, and we run it. Boom, there's our second set. No colons because I didn't put it into the print. Yeah, that's traversing a dictionary. Pretty easy. However, what if our dictionary is a little more complex? Let's say we have a grades dictionary. I'll just put it up here. And what if I want to traverse this? Well, they're all similar, right? So that's a part of programming, is we're control of the data structure. So I know that I could still say for like key, well, let's say for name, comma, grades in grades. Ooh, let's call this class grades. And dot items. Now I can say print name, comma, grades. Okay, so the grades comes out as a list, but if I wanted to process the grades, I could just say, well, print out their max grade. Okay, but oh, I messed that one up. Let me fix that data. Should be a comma. Okay, so but that's kind of going around the point I was trying to make. Let's say we want to, let's say we have to process their grades, and it's not fair because Python has built-ins for everything. But let's say we want to manually calculate their average. I would have to traverse this list and get every value. So we could do another for loop. So for G in grades, print G. So this will just dump all of them out, right? But you know this is going to loop that amount of times for each student. So before that inner loop, I could say sum is equal to 0 and sum plus equals the grade, and then outside of the loop we just go even with the 4 I can say print G div. Now, I should have counted them, but the value grades has a length, so we'll just divide it by the length of the grades, and that should give us the average for each student. It's a little disconcerting because I didn't do formatted strings and I was printing out every value. So let's see if this makes a little more sense. There we go. So I have the name. Let's do this. Name, comma, colon, comma. There we go. And that's some pretty long stuff. So let's see if we can round that. I needed a... Okay, there we go. Alright, now we're at 6 minutes, but I have one more example. Hey guys, last video got cut off, so I'm just going to go over this traversing a dictionary of randomly collected items, in other words, Randy. So this has basically a regular entry. It has a key that points to a list of items. It has a key that points to a dictionary of items. And this is not a good way to store your data because it's not consistent. But we can still traverse this data structure and access each of the elements. So for key, comma, value in randy.items, print key, comma, value. Alright, we all know how to do that. But the thing is, we want to handle each of these instances differently depending on what data type these values are. So what we could do is say, if the type of the value is a list, do something. Elif the type of the value is a dictionary, do something. Else, we're just going to assume that it's regular string, so we'll say print formatted. No, I won't do a formatted string. We'll just do print key, comma, value. But if it's a list, we want to traverse this and do something with it. So for I in val, print I. And I could say print key, colon, and it'll print all its values. In fact, we could maybe tab them over. And we'll see what that does. And then for our dictionary, same idea. But now we know that val, so key is key, and then our value is an entire dictionary, so we need a whole something similar to that. So we can do sub key, comma, sub val in not randy.items, but just in val, because that's the dictionary now. Print I can't decide which way to print it. So we're going to say print dictionary. This is just for us. Up here we'll print, it's a list, and then we'll down here we will just print whatever. We don't need the key for this one. So this says too many values to unpack. Usually you're trying to access something like it's something that it's not. So what I did not do was, which I always forget this, like in C++ programs I always forget system pause. So I forgot my items to unpack it. There we go. So the first one it caught was, well, just the regular one, so whatever, key value. Then we got a list and printed those with the tab, dictionary. Alright, this is ugly, but now we know how to test for different data types. That should be good. See y'all in a minute.